Hello, welcome back to my channel and welcome to chapter 6 of the cross origin resource sharing course. And in this chapter, I want to talk about the course syntax. In the previous chapters, or the most recent chapter, I had mentioned that I'm going to go on to credentialed requests, which I mentioned is a request that has credentials in the header, but I realized that there is some preliminary information that will still be had, will be necessary to actually understanding credentialed requests, especially an understanding of the syntax of cross-origin resource sharing. So I think in future videos I'll not be mentioning what I'll cover next. Maybe I'll just say in a future video we shall cover this because there's some information I keep finding and anyway, basically that's it. I want to slot this in to make sure that we don't miss some necessary prerequisite understanding before diving into a topic. So basically, if you think about, let's just get it started. If you think about any programming language you use, you basically have to learn the syntax of the language. Then after learning the syntax, then you can give instructions that can then be compiled. You can code, and then the code will be compiled. If you get the syntax wrong, then the code will not compile or it won't run. So similarly, for cross-origin resource sharing, there's a syntax we use. It's used between the server and the client to communicate the policies the server has set around cross-origin resource sharing or cross-origin requests. So an understanding of these headers or the syntax is very key. And as I mentioned before, CORS is just a protocol for relaxing the same origin policy in a controlled manner. And basically, how it does this is by extending the HTTP protocol by adding additional headers. And these headers are the only way we can implement cross origin resource sharing policies in browsers and clients. So, an understanding of them is very key because the headers make up the syntax, of course. So I have a diagram here that has a full list of the headers. Some of them are set on the client side, some of them are set on the server side. Request headers versus response headers. So let's just take a look at this diagram and start on the client side on my right here. The first header that is used by the client is called the origin header. We've already, in all our demos before, we looked at the origin header, and it's described as the hello world of the course specification. It's the hello world because it's the simplest configuration you can make that even resembles cross origin resource sharing spec. So, origin is basically the hello world. And as we saw earlier, the browser run scripts in it. And when these scripts are trying to make requests to servers, it passes through the browser, of course. The browser will analyze the request and decide what to do accordingly. So for cross origin requests, the browser will read the request of the script. It will take note of the origin to which the request is going and take note of the origin of the script. And if these two origins don't match, then the browser is under obligation to find out exactly what are the CORS policies from the server before allowing this request to go through. As we'll see later, there are some times when the browser deems the request safe and just sends it. However, it will still attach the origin header. So one could say when the browser detects that the request is cross-origin, the first mandate it has is to append an origin header in the request so that the server can know. Okay. And then the next header is access control request method. And since we've been talking about mainly origins, we now have more request parameters that are watched actively and cautiously applied by the browser when they encounter. One of them is the request HTTP method, whether it's a get method, post method, put method, delete method. The browser will read it and then decide is this HTTP method safe to use by default? If it is not considered safe based on the policies of cross origin resource sharing, then the browser can block the request. unless if the server says explicitly that requests that are of type put or delete or whatever HTTP method used by the script are allowed. If the server doesn't say this and the client doesn't consider the HTTP method to be safe, it will block the request. And the last header is access control request headers. Similar to HTTP methods, there are also HTTP headers. One thing I should mention is that the HTTP protocol has a standard set of headers it uses in communication. And we mentioned that headers are metadata shared between client and server in the client server model. This metadata helps to enrich the message sent by the HTTP message sent by the client, and that's responded to, and that's sent back by the server. So access control request headers applies to headers that are considered custom. And as we mentioned, you can extend the HTTP protocol the same way the CORS specification extends the HTTP protocol by adding additional headers. These headers are custom headers, but they belong to the cross-origin sharing spec. But you can also add your own custom headers, and that is understood by your clients and servers, and communicate some information in it. Maybe you have microservices and you want to append the name of the microservice in a response header, or you want to append the chain of microservices, the names of the microservices in a list of headers and send back to the client. All right, or you want to append a client app's name in the request, and you create a custom header for that the server will understand. All of these are options you can use, and basically, if the header is just an extension that you've created and it's not part of the standard HTTP headers, then the browser is under obligation to flag it, and the browser may just simply eliminate the header from the request. Okay, but that happens if the browser eliminates that header. It could be that it does not know whether the server accepts these custom headers or not. But ultimately, it's under obligation to not just send any custom headers by default. Okay, so moving on to the left-hand side, we have the response headers. Please take note that this is the exhaustive list of headers sent by the clients in cross-origin spec. All right, there is no other headers. So this is the syntax from the client side, nothing else. You understand this, you've understood the mode of communication of the browser as regards CORS. So moving this side to the response headers, these are the headers sent by the server to the client. So if you look at the first header, is called, most of these have the roots, the name is prefixed by access control, because basically that's what is happening. We are doing access control to the user's data. So access control allow origin. Basically, it's a response to the origin header from the client. So when the server receives a request and it checks if this header exists, the origin header exists, and indeed the header exists, then the server will know that this is a cross-origin request. But if you send a request, for example, from Postman, and you don't append that header, it will be processed without CORS guidelines. So you see, CORS is a collaboration between the browser and the server. If the browser, for some reason, is not compliant and it doesn't include this origin header, then as a matter of fact, the user's data is at risk. That's why users are encouraged to use compliant browsers that are trusted, because a browser, because of its negligence, could expose your data, could open channels for exposing your data or your users' data to hackers. So a CORS compliant browser will always send an origin header when the script sending the request is not from the same origin as the server. So the server receiving this kicks off the cross-origin resource sharing flow. And one of the first things it does is to set a header called access control allow origin, which specifies exactly, which tells the browser if the origin is allowed or not. Based on the value of this, the browser will be able to either block the request or accept the request, depending on the setup on the browser. So the server could set a couple of values for the access control allow origin header. And one of them is the server could set the value star or asterisk. What this means is that any origin can send a request to the server. So this is the way in real life you can just look at this as public APIs, an API that is not seeking to control access to its data. There is no damage done. Even if the request is coming from a malicious script, there's nothing it can do with the data. It's not even user data. For example, the weather API, you can't steal weather API data really, because weather API typically is just maybe if they're control if it's behind a paywall and they're trying to control, but that those are different mechanisms. However, access to that data does not endanger any user, right? So the owner of that server may set the access control allow origin header value to a star or asterisk, meaning a wildcard value. Any origin is okay. And then the other option is to have to configure a list or a set of origins that are considered safe to to receive requests from. So the developer may configure maybe one, two, three, or any number of origins. And when the server receives the origin header from the client, it basically checks in its list of origins and um, decides based on if there is a match for the incoming origin or not. And the browser will respect that response and either accept or block the request. The third option could be that the browser sends the origin, but the server simply reads the value of that origin, sets it, and sends it back. There is no list configured. There is no other configuration. It just copies the origin. It's like a reflection. The browser sends the origin, the server sends it back. Why would this happen? This is called dynamic access control allow origin value. This There are some use cases for this. For example, one could say, why not just allow everything with the asterisk or star? But there are some caveats put in place by the CORS specification to protect the user data in the event that this is a public API or you've configured it as public, because it's the developers to do this. So when you configure asterisk or wildcard, then the CORS specification says don't share some kind of data or have some limitations. And if, as a developer, you still want to allow every origin to send a request for whatever reason, but you don't want those other restrictions to happen, then you can just reflect back the origin that comes. Effectively, what you're doing is you're telling the client, allow this origin, okay, to send a request to me. But how are you allowing it? Based on what? All right, these are all the decisions by the developer, but effectively, the client doesn't have a difference between a reflected origin header and an origin header picked from a list, but matching the origin of the script. So there are use cases for that. It's beyond the scope of this video, but I just wanted to mention that as a rationale for using one or the other for allow origin header. Then the next header is called access control allow methods. This is a list of HTTP methods that are allowed by the server for requests coming from cross-origin scripts. And it's a response to the access control request method header. So we said that the browser will put the HTTP method in this header and send a request to the browser, to the server, to decide whether that HTTP method is allowed. Then in response, the server sets access control allow methods header with a list of HTTP methods that are allowed. And I put these three values here because by default they are considered safe to get requests from cross-origin scripts. The get header is considered safe, post is considered safe, head is considered safe. Basically, when the script is using any of these methods, it's considered safe. However, notice the star I've put on the post method, because if you're used to the HTTP protocol, you could have a red flag going in your mind. Well, if you say a method is safe, that means it's not making changes on the server, but post is actually making changes on the server. But remember, post is used for creating data. Typically, you're creating new data on the server. Maybe even this data could be appended to some other data that's already existing, but it is less risky than put. Put is changing a record that is already existing. So post is less risky than put. That's why it's here, and and that's not all. There are some caveats put in place. When the browser encounters a post request, it will say this is 50% safe. Reason being, there's some additional caveats. It will check some other parameters of the request and make a final decision whether this is a safe request or not based on the values of those. So it's not considered only on account of the HTTP method. Let's just keep that in mind. Then the third header is called access control allow headers. It's like access control allow methods, but for headers, and it's a response to the access control request method. So we already talked about this, how you can create custom headers and use it to enrich the communication between the server and the client. So the server will respond to this request header by adding access control allow headers. And typically, as a developer, you will have done a configuration in your CORS configuration by adding some custom headers that you want to be exchanged without any problem. So when these match, the browser will accept the request. And then the fourth header is access control max age. What is that? The access control max age is basically a time value, a duration value, and it's counted in seconds. So access control max age 1,800 seconds is 30 minutes. But what does it really do? So it's a directive by the server to the client about cache considerations. So typically, these settings of response headers for cross-origin resource sharing, when the browser receives them from the server, to prevent itself from calling the server over and over to get these configurations, the browser will cache them locally for the user, such that the next time it encounters a cross-origin request from the same origin, and maybe possibly, basically, it does some checks to know if it can use the cached value. So it will check if the configuration is already in cache. If it's in cache, it doesn't request a server to share them again. So this is a directive by the server to tell the client, if you're caching these values, don't cache them for more than 30 minutes. You can configure this value on the server, maybe to an hour or a full day, and the browser will respect that. The aspect of caching is a whole beast on its own, and it's beyond the scope of this video, but maybe I'll cover it in the future. Then the second last one is called access control allow credentials. So basically, this is related to the type of request we talked about earlier, private requests or public APIs. Like we said, the access control allow origin can have a star value or wildcard value. And that means that any request from all over the world from any origin is allowed. However, access control allow credentials is the server telling the browser whether requests from cross origins should include credential information like authorization information or cookies. So if the access control allow credentials value is true, then the script sets some authorization or cookies, or even the cookies session cookies set by the browser by default, then these will be sent over the wire in the request. However, if the server said false, then the browser will strip off that data in the default mode. Maybe you can configure that the server must include these values. In which case, if this you can configure the browser to include the credentials, but because by default it will remove the credentials from the request. But if you explicitly configure it to include the credentials, then the browser will ask the server, and the server will respond with the access control allow credentials header. If the value is false, then the browser will throw an exception and fail to send your request so that you attend to that issue. And I had mentioned while talking about access control allow origin that when you set the star header, you're accepting requests from all over, from any origin. But there were some caveats. So one of the caveats is that by default, if the server is allowing requests from all origins, then by default, the browser is not going to send credentials. That was the caveat I was talking about. And then some developers want to be able to allow all origins, but also allow credentials at the same time. That's why they trick the browser by just reflecting the origin value that was sent to the server, by reflecting it back, so that the browser sees this policy as allowing this particular origin the script is using. So I hope that one is clear. And I also mentioned that it's a bedrock for a lot of vulnerabilities in the browser. And that's why it's important to use compliant browsers, and also it's important to set your course configurations right to protect user data. And then the last response header is called access control expose headers. The best way to understand this is that when we looked at access control request headers, we talked about headers that are in the script request. Before the browser sends it to the server, it looks at the request headers. If any of them are considered unsafe or unknown, as is the case for custom headers that you set, then the browser will send this to the server, and the server will respond with access control allow headers. And the browser will be able to tell, okay, is any of these headers not allowed? Now, for expose headers, it is to do with the headers from the server side, all right? The headers from the server side that are set as a response, custom headers. When these are not listed in the expose headers, then when the browser receives them, by default, it will not expose them to the script. So if you do response.get headers, then the browser will refuse to give this to your script. That is the caveat. And if you want your scripts to access a certain header, then you must explicitly list that header under access control expose headers. So what we've talked about is basically the entirety of the course syntax. This is all you're going to do when you're dealing with course. Every policy you want to set for your for your clients or servers is going to be set using either these response headers or these request headers, and there's nothing else. So an understanding of these headers is very key in understanding how to configure cross-origin resource sharing. So this video is already long enough, and I want to cover something to do with the access control allow headers and access control allow methods. No, it's allow headers and basically allow headers because there are some caveats. Remember, I mentioned that post request is considered safe only to the extent that it doesn't include some kind of data. So we're going to look at that. What are the caveats in the next video, so that this video is not too long. Thank you very much. See you then.